Hello guys, my name is Desmond. A very warm welcome to my lesson for today, where we will be looking at mathematics. Ladies and gentlemen, as always, Shanti Shanti, please do allow me to say it is very much important that I say it is very, very much important because what I'm about to say, it's massively Sinotile Dube. Massively important, ladies and gentlemen, that I say a day without learning something new, it's a day wasted. Bantu Bakiti. Please, honorable members, please do make sure that by the end of each and every lesson that I conduct, you learn something new. Very, very much important, ladies and gentlemen, over there. So I'm pretty much sure that all is clear, all is good from your side. Maybe one last confirmation. Clear, and can you clearly see there?
Yes.
Okay, Hamisa, thanks for that confirmation. Most importantly, for those of you guys who joined my lesson for the very first time today, just make sure to remain muted. You only unmute if you've got a question. So this is what I'm going to do in today's lesson, trigonometry. We are just going to do an introduction. Consider yourself very lucky in case if you manage to attend today's lesson, because we are now starting with this new chapter, meaning we are not going to be solving any exam problems, but I'm just going to take you through an introduction where under unit 1 we focus on a right angled triangle. Remember, when I do introductions, it's just me telling you all that you need to know, all that you need to be aware of, so that when we start answering exam type question papers, you already have an idea of what you should be aware of what you should know. So remember, guys, when we are dealing with trigonometry, in simple terms, we are actually studying the relationship between sides and angles. It is as easy as that. The word trigonometry, if you go deep and research that word, you might find that it's a Greek word which simply refers to a measure of a triangle. So it's more like we are only interested in the relationship between the sides and the angles of a triangle. Trigonometry, measure of triangles, I meant to say. So remember, this is a triangle. What makes it to be a triangle is because it has one side, two sides, three sides. So that means a triangle has got three sides. Also, three angles. Three sides, three angles. It doesn't matter in which direction the triangle is facing. What matters the most, it has three sides, three angles. Very, very much important, ladies and gentlemen, over there. So now we've got types of triangles. I think you can have a scalene, you can also have an isosceles. But in today's lesson, specifically under a trigonometry, we focus on a specific type of a triangle called a right-angled triangle. So at all the times when I talk about trigonometry, always remember a right-angled triangle. So now, how do you see, or how do you know this is a right-angled triangle? Remember, what we know is that this is a triangle. Why? Because it has 1, 2, 3 sides. 1, 2, 3 angles. But now, what makes it to be a right-angled triangle? That's when you see that 90-degree sign. If you have this is not a right-angled triangle. Why? Because we are not told and we don't see the 90-degree angle sign. If we don't see that, then it is not a right-angled triangle. Always remember that. Okay, so because we see that sign of a 90-degree, that means this is a right-angled triangle. So remember, guys, since we are studying a triangle having 3 sides, these sides have got specific names. What are those names? Normally, a hypotenuse, I'm well aware that you're not hearing that for the first time. The other name, opposite, and the other name is adjacent. So obviously it's going to be 3 names. Why? Because a triangle has 3 sides. But now, which side is which? Okay, so we know that the side opposite to that 90-degree, that one, is what we call hypotenuse. But now the question is, which side is adjacent and which side is opposite? Just to make it easy, let's say this is A, this is B, this is C. Just mention your name and I will recognize you. As always, don't just unmute and you give an answer. Mention your name and I will recognize you. Here comes the question. I've just indicated that side AC is called hypotenuse. Why? Because it's opposite to the 90-degree angle. My question is, which side, AB or BC, which side is opposite and which side is adjacent? Mention your name, I will recognize you.
Chantal.
We have Chantal. The other one who would like to also give it a try?
Jackie.
Minentle.
Okay, Minentle, you are recognized, honorable member. On what point are you rising?
AB, it's an opposite.
AB is opposite. Okay, Shanti, go for it, honorable member. You are recognized.
AB is the opposite, and then BC is adjacent.
Opposite, and then this is adjacent. Okay, this is what I'm going to say, Bantu Pakiti. Let me see. Remember to remain muted, honorable member. Charlotte, are you there, honorable member? I want to tell you something because I know you do know this very well. Charlotte, do you remember when I said we have honorable members in grade 12 having their problems which are not in grade 12? Do you still remember this?
Yes, sir.
So the reason why I was saying this is because of both honorable members. They are incorrect. And I know someone is thinking BC is opposite and then AB is adjacent. Even this honorable member is correct, Charlotte. And the reason to that is because of them not having an understanding of how these things work. They did all of this from grade 10, they did in 11, now they are in grade 12. So the reason why they might find grade 12 challenging is because of them lacking an understanding. So now, what I'm hoping to achieve in today's lesson is for you guys to understand and not only know, but understand. Let's maybe try to work it out. Shanti, are you still there, honorable member, while Minentle and everyone else will be listening?
Yes.
Okay, so for you to know which side is opposite, you need a reference angle. What is a reference angle? I need to tell you to say the reference angle is there. Then, once you know the reference angle is there, then the side opposite to the reference angle is what we call opposite. And then this one would be obvious being adjacent. That is why you can have this side being adjacent and this being opposite, or this being opposite, that being adjacent. What determines that? It is the position of the reference angle. If I now put the reference angle there, can you see? That means this side changes, and then this is going to be opposite, this is going to be adjacent. But this one, which is opposite to the 90-degree angle, it doesn't change. It's the obvious or the easy side. Minentle, does it make 100% sense, honorable member?
Yes, sir.
Sir,
Yes.
you say that we were both wrong. Is it because you didn't give us a reference angle? Because I made mine C. Since you did not think give us one.
Sure, I couldn't hear that, honorable member. What did you say there, Shanti? Can you come again?
I say that when I answered right, I made my reference
Mhm.
angle. So are you saying that we were both wrong because there was no reference angle?
Yes, that's correct. So what I'm saying is I did not give you a reference angle, meaning examiner did not give you a reference angle. So if you put it there, whereas it was given somewhere in the statement and they said there. So can you see, it's more like you assumed for it to be there. And not follow what was given. So it means in this case, it was not given. And a response that I expected was, we can't tell at this stage which side is which because we do not have the reference angle. Make sense, Shanti?
Yes, I understand.
100%. So, Bantu Bakiti, that's all that you needed to know and remember with regards to a right angled triangle. So, the last thing that I need to mention is that this thing, is it a right angle triangle? No. Why? Because I don't see what is it, a 90-degree sign, and again we are not told. But the moment I do that, then yes, it's a right angle. Obviously, this side is the one which is hypotenuse. Okay, so now which side is which? Adjacent, opposite? None. Why? Because I don't have the reference. Okay, now this is okay, meaning this is adjacent, that is up. Okay, so now most importantly, you need to remember that the sum of interior angles of a triangle add up to what is it, 180, meaning when you say angle A, you plus it with angle C, you plus it with that, it has to give you 100. So that means angle B, of which we know it is 90, when you plus it with angle of A, which is unknown, plus it with angle of C, which is unknown, it must give you 180. So that means if you can manage to get angle A or angle B, just substitute it there, then you transpose and then you know what is the value of the other angle. So that's what I also wanted you guys to remember as far as a right angled triangle is concerned. So I think now I can just quickly remove all of those. Remember, we are still under unit 1 where we talk about a right angled triangle. But remember, because you guys are in grade 12, you are very much close to being a university student. So now we take things a bit deeper. So you are having this thing called a Cartesian plane. It's in most cases where most of your things will be referenced to a Cartesian plane, where we know that from that line of the x-axis, we have an angle being 0 there. And then from that 0, if we rotate in this direction of anti-clockwise, we end up having 90 degrees there. You do know very well this 180 there, 270 there, 360 there. So most importantly, we know that a Cartesian plane has got 4 quarters, which we call the quadrants, meaning this is going to be quarter number 1, meaning quadrant number 1, whether you say I there doesn't matter, quarter number 2, whether you say I there, and then here we're having quarter number 3, whether you say triple I there doesn't matter, and then here we are having quarter number 4, of which you can still say this is a IV. Most importantly, this lesson is being recorded, so you might not need to worry about writing what I'm writing, but it will be posted tomorrow and you can still catch up. Most importantly, all the angles which are within quarter number 1, we call those angles acute angles. So that means if they say 13 degrees, can you see it falls between 0 and 90? We call it an acute angle. So now let's see angles here obtuse. Can you see this type of information is there in grade 10? If you forget, you might not easily answer. So I think this one is reflex, a reflex angle, and then here, if I remember, is revolution. Yeah, revolution angles between. Okay, so now something very much important that you need to remember is that since I said a right angled triangle will be drawn on a Cartesian plane, so you are going to have this type of a line which starts from the origin and then it could go in that direction, of which this is what you normally refer to as your R, being your radius. The other name is called terminal side. If you like, if you don't want to call it R, you can just call it a terminal side. But what I want you guys to be aware of is that through a terminal side, that's where you form a right angled triangle, having this line being parallel to that line, meaning it's a straight vertical line forming a 90-degree angle there. So that means if you have a terminal side or your R in that first quadrant, then you are having a right angle triangle looking like that, with your angle being that one there. Otherwise, if it's this side and then you have it there, and it forms something looking like a butterfly, that is why it won't be easy for you to forget this drawing, just for ease of reference. And most importantly, we know that in the first quadrant, we always have positive x values, positive y values. So if we had to use the names of the sides, obviously this is our reference angle. So y will always be opposite, x will always be adjacent, and r, it is the one which is your hypotenuse. So that means the moment a right angled triangle is represented on a Cartesian plane, we no longer talk opposite, adjacent, hypotenuse. Those are left in grade 10 and 11. We now talk about your y, x, and r. So this, the terminal side, will always be your r. The x will always be there. You just need to remember that here it's a negative x. Obviously, a negative y, a positive x. Negative x. R always, 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 always positive. Remember that. So you can take a screenshot of this, or otherwise you just need to remember that this lesson is being recorded and at a later stage you can catch up. So that's all that I wanted to discuss under unit number 1, where we discuss a right angled triangle. Very quickly, I'm going to move on to a unit number 2, where we discuss the definitions of trigonometric ratios. So remember, guys, it's not everything which might make sense in today's lesson, but if it makes sense, it could be because you've been attending my lessons since the past years. It could be because you've already started with this chapter. It could be because you've got a better understanding. But if you are doing this chapter for the very first time, or for some reason you are in grade 12 and you don't know how you got there, that's when you might not easily understand all of this. But when we start solving exam type of question papers, that's when everything is going to make some sense. So do not worry that much in case if you are lost. But one thing for sure, if you are late for lessons, you will definitely be lost. And that's why I encourage you to remain muted and catch up, then ask questions on next lesson. Okay, so unit number 2, we talk about the definitions of trigonometric ratios. I want you guys to always remember trigonometric ratios, because it's in most cases where I'm going to be saying trigonometric ratios. Okay, maybe let's break it down. When we talk about those trigonometric ratios, remember, ratio means something over something. That's a ratio. That's what a ratio means. So if you get 1 over 100, this is a ratio. If you say 2:4, this is a ratio written in different forms. This is the first form, this is another form, this is another form of representing a ratio. But listen very, I'm talking about trigonometric ratios. What are those? We have 3 trigonometric ratios. Number 1, let's maybe say sine. Number 2, let's say cos. Number 3, let's say tan. Bantu Bakiti, are you still there? Or are you guys watching Gomorrah there?
It's not silly. We're still here.
Last one to confirm.
We're still here, sir.
Still here.
100%. I will confidently continue. Okay. So, trigonometric ratios. We talk about sine, cos, and tan. I think you guys still remember, what is it? SOHCAHTOA. Yes, something of that nature. Okay. So, since we are talking about a ratio, what ratios? Trigonometric ratios. I've just indicated that under trigonometry, we are now talking about either x, y, or r, where x, it refers to adjacent, y refers to opposite, and then r refers to hypotenuse. So we do know very well the ratio for sine is sinoa, opposite over okay. So that means the ratio for sine is opposite over a hypotenuse. So in terms of those letters, opposite we say it's y over r. Let's see, for cos we know it's what, adjacent, cosine, adjacent over hype, meaning it's x over r. This one obviously is opposite over adjacent, tanua, and then what is it? It's y over x. I'm 100% sure that you are not seeing this for the very first time and you fully understand those. You just need to remember, whether you say SOHCAHTOA or whatever that you say, which will help you to remember those. Just make sure that you stick to that. Most importantly, I'm about to now introduce something very interesting, and I would like to request you guys to listen very carefully. Volani madle bebantu bakithi. I'm about to speak some big words there. Listen very carefully. The reciprocals of the 3 trigonometric ratios. So that means what I've just explained, all of this is referred to trigonometric ratios. Now I'm talking about the reciprocals. You know, most you've got original and Hong Kong. So assuming that this is original, the Hong Kong of this original is what? I think it's inverse. Yeah, inverse. Otherwise, if it's not inverse, as soon as you realize what I'm talking about, you will know what is the Hong Kong of that. So that means during winter schools, even though, remember guys, as we don't close, during your school holidays, you still attend as always. The only time we're going to close is in November, your last exam. So I'm just saying, in case if during winter you go to a different school for your winter schools or whatever, and they ask, use this word, reciprocals. I'm telling you, everyone is going to, what are the reciprocals? Bantu Bagiti, I'm talking about what is it? You know sec, cosec, and cot. I'm telling you guys, these three things are what we call the reciprocals, or the inverse of trigonometric ratios. So that means in today's lesson, you've learned we have something called trigonometric ratios, which is sine, cos, and tan. And now we talk about the reciprocals. So let's see. Sec, it's a cousin of either sine, cos, or tan. This one, a cousin of this, that, or this one, a cousin. So let's see whose cousin is who. The reason why I like this type of classes where you guys attend is because I've learned this last year from a learner called LB. She's in different school, and she said, for us not to easily forget, we look at letter number 3. What is letter number 3 of sec? Let's see. 1, 2, 3 is C. So that means this C is the cousin of cos. Let's see. What is letter number 3 there? 1, 2, 3. Letter number 3 is S. This S, it means sine. So that means cosec is the cousin of sine. Let's see. What is letter number 3? 1, 2, 3. T. T for tan. So that means the cousin of tan is cot. Jackie the Jackies, does it make sense, honorable member? Are you sure I'm not losing you there?
Yes, sir. I'm okay.
100%. So if you guys remember, we said a sine, it's actually what? Sino, y over that. So what is the cousin of sine? The cousin of sine is cosec. So that means cosec is the inverse. That's why I said the fonkong of that is inverse. What is the inverse? The inverse, you know, you take this, which is at the top, at the bottom, take it to the top, at the top you take. So that means cosec is actually the inverse of that or that. This is how it looks like. And then for cos, we know cos is x over r. That means its cousin is just r over x. Same thing, but you just swap. And then for what? For tan, we know we are having y over x. And then the cousin of that is going to be x over y. You can still take a screenshot, or remember, this is being recorded. You can still catch up. Also, at your school, they might not do it this way and say, when it comes to cosec, it's actually 1 over sine. Or they say, this one, it's actually 1 over cos. Or this one is equals to 1 over tan. It refers to the same thing, because if you substitute there, you're going to have 1 over, what is that? That, because they said 1 over sine. So substitute, that means you're having y over r. And if you simplify this, it's going to take you to where you end up having that, which is that. The same applies for this one and also for this one. Whether you write it this way or that way, if you substitute in terms of r and x, I mean x and r, y and x, it is still going to take you back to that ratio. So that is why I'm saying they can teach you in this format or in that format. It refers to one and the same thing represented differently. Ladies and gentlemen, that's all that I wanted us to discuss under definitions of trigonometric ratios. I'm now about to move on to unit number 3, where we talk about special angles, angles which are special. Any question there before I move on quickly, or are we all okay that side?
I'm okay, sir.
Chumi the Chumi is okay.
I'm doing well, sir.
100%. Buddha is okay that side. So very quickly, we will now move on to unit 3. Remember, guys, to some of you guys, this might be boring, but I'm telling you, everything that I'm going to be doing when we do some complicated questions, this is where it starts. So this is the starting point of your problem. Chumi the chumis. Remember to mute your mic, honorable member. Okay, let's see. Unit number 3, we are looking at the special angles. And I'm sure you guys know about the special angles. Maybe let me keep it simple and say we have 3 special angles. Maybe let me start with this easy one, where they say if this angle is 45, that angle also has to be 45. Why? Because when you add 45 plus 45 plus 90, it has to give you 180. So they say this side will always be 1, being adjacent or being opposite. And then when you use the theorem of Pythagoras to find that, it will then be a square root of 2. So that means every time when you see an angle being 45, your opposite will always be 1, or your adjacent will always be 1, and hypotenuse will always be square root of 2. Another special angle. Remember, you will always have 90-degree angle there. So they're saying, for example, if you are having 30 there, you will always have square root of 3 being your adjacent, you'll always have 1 being your opposite, you'll always have 2 being your hypotenuse. And then the last one being this one. Remember, it has to be a 90-degree. Why? Because it's a right-angled triangle. Maybe angle 60 being there. They're saying you'll always have square root of that, you'll always have 1 there, you'll always have 2 there. So if you can look very closely, you will realize that these 2 triangles are actually the same. The only difference is the position of that angle. But in terms of there is 2, there root of 3, there is. That is why they combined those 2 and made it to be 1. Meaning here they know it's 60, there is 30. And you will always have that as 2, this one as the root of 3, and then this one as 1. That is why your teacher might say those are your 2 special angles that you must always know by heart, because they won't be given to you in a formula sheet. So that means these are your special angles, Bantipakiti. Something that I think I need to remind you is that every time when you are dealing with a right-angled triangle, always when you are dealing with a right-angled, okay, is this a right-angled triangle? No. Why? Because we don't see the 90-degree. Okay, now we have it. Yes, it is a right angle. So that means any question related to a right-angled triangle, you always use either sine, cos, or tan, and lastly, theorem of Pythagoras. Maybe let me write it this way so that it's easy for everyone to. So these are the only things that you can use when you want to calculate either the sides or the angles involved as far as trigonometry is involved. I'm not including additional questions where they might say calculate the area of that triangle or anything else. But most importantly, whether you want to know the length of the sides, use the trick. Length of the sides, trick. The angles, trick. Did that make sense, honorable members? This together with the special angles. Before I move quickly to unit number 4, which is very quick also.
Yes, sir, that makes sense.
Yes, sir, it makes sense.
Okay, 100%. So remember, guys, this is me doing an introduction. It is going to be very easy, and to some extent, it could be boring. But most importantly, just remain until the end. Someone is wondering, since we are talking about a right-angled triangle, what if it wasn't a right-angled triangle? Okay, maybe let me quickly answer that. If, for example, you have something similar to that, can you see it's not a right-angled triangle? This is where you now use the cosine and the sine rules. I'm sure you remember these rules. So I'm sure now you have your eyes open to say, okay, we only use trig ratios under right angle triangle. If it's not a right angle triangle, that's when you use the cosine rule. I'm still going to teach you those maybe on our next lesson or sometime next week. But for now, we are only focusing on a right angled Okay, let's say we have 12 centimeters there, we have 4 centimeters there, and the question says find angle P and angle R. I won't ask you this one, but I'll just quickly explain just so that you guys are aware that the math that I'm doing is the same as the math that you are doing. So remember, when dealing with a right angled triangle, you just need only two things to calculate the third thing. It's either you have an angle and a side, or you have what else? You could also have the sides, just like it's given there. You have a side and also you have another side. So in short, whatever examiner could ask yourself, do I have two things? If you do, then you can calculate it. So can you see 1, 2? That means I can calculate. Now they want you to calculate angle P. So can you see, honorable member, when they say calculate angle P, it's more like they're saying now P, it is your reference angle. That's how you're going to know that this is actually the opposite. Why? Because it's opposite to that angle that you want to calculate. So obviously, you need to know which trigonometric ratio, sine, cos, or tan. Why do you come to trig ratios? It's because you know this is a right angle triangle. How do you know? Because of that. That's why you consult those. So let's see. I think for this one, you will obviously use sine because you have your opposite over hypotenuse, and then you find the second function of that. That's how you get your angle P. And then now that you know what angle P is, you can still do that one of saying, since you know that the sum of interior angles of a triangle equals 280, then you can just say angle P, you plus it with this one, we already know it's 90 plus angle R is equal to 100. Then you take this to the other side, and then that's how you get your angle R. Or otherwise, someone can say, I don't want to use this because it forces me to use the angle that I got for P. And what if that angle is wrong? That means this is also going to be wrong. Therefore, I won't use that method, but I will use one where I actually work with the given information, meaning this is the reference angle. Can you see Shanti or Minentle? What was opposite to that angle? It is now adjacent to this angle. So that means, let's see, I think it's cosine, where you are having cosine adjacent over hypotenuse, and then you can say the second function of that, it is going to give you angle R. And also, if you want to calculate the side, you can still do that using either this angle or that angle. I'm pretty much sure that it makes sense, Bantubakiti. Anyone who's got a question on that one before we quickly move on to the next part of our lesson? Anyone who's got a question? Or did that make sense to everyone?
Yes, sir.
Okay, 100%. So very quickly, I will move on to the relevant part of today's lesson because I've actually included some other parts of this lesson when I started. So that means from what we have done up to this point, we won't need to do unit number 5, which is solving trigonometric equations. You will notice that as we do exam type of questions, but it was actually included, so you didn't miss out anything under that unit. Extending ratios from 0 to 360, it falls under unit number 6. You haven't missed anything there. So it is actually this one where I was saying you have a butterfly. So it's actually included in that. So I don't think you have missed anything there. So now let's move on to unit number 7, where I just take you through the process of sketching trigonometric functions. But remember, these are just the basics. I'm not teaching you how to calculate or how to plot the complicated trigonometric functions. I'm just doing the basics so that when we get to complicated stuff, you will have an understanding of where we are coming from. So graphs of trig functions. Yes. So let's start with the sine and the cosine graphs. Sine and cosine graphs. Let's say, for example, let's just keep it simple and say they say plot the function of y is equals to sine angle. And they're going to say your angle is the element of, they give you a range from which you should start and end. So sometimes they can say negative 360 degrees, and then they can say positive 360 degrees. So when you sketch, you firstly focus on your range, which is that one. So this means on your Cartesian plane, start from negative 360. That's what it means. And then also end on positive 360. So we obviously know that we have negative 90 there, negative what? Negative 180 there, negative 270 there, negative 360 degrees there. We have 90 there, we have 180 there, we have 270 there, we have 360 degrees there. Jakes, I know, honorable member, you are one of those who are attending extra weekend classes and you fully understand beyond what I've just explained there. So remember, Jackie, with regards to extra weekend classes, that's where you learn ahead. So I know everything that we are doing here. You might know, you have an idea of everything, but in today's lesson, I'm not going to explain how did I know I'm having 90, 180, 270, 360, because we are still getting there. For today,
Yes.
it's just introduction, just like we did. So don't be surprised when I don't explain the period, the range, and whatever. We are just doing it's more like a warm-up, if we can take it that way. So don't worry, Bantu Bagiti. Kusa so shuba. This is just the beginning. Kusa so shuba. Okay, now I'm done with that part of the range in terms of where to start your function and where to end it along the x. But you know, over time, I realized that actually, if you remember, we had 0, 90, 180, 270, 360. So it's more like we are having this same circle, but now it's actually represented on that x-axis. So all these angles, they are actually represented there, starting from 0 being that one there. And then you have it from 0 up until 360. And then you still have the same on the negative side. So with regards to plotting, if you are in grade 12 and you're struggling with this type of problems. It's because you missed this type of information. Those questions are complicated in grade 12, and it gets worse if you don't have this kind of basic. So now, to plot, you just punch those angles there, starting from 360. You make a dot, go in there, make a dot, go in there, make a dot. Hey, it's as easy as that. Let's see. Voga Malamba. Voga Malamba. Yes. Uvugile Malamba. Let's see. You just say sine. You start from that negative angle. It's negative 360 degrees. What are you getting? I'm getting 0. So you guys punch and give me. There it's 0. What about that one? Let's see. Negative 270. I'm getting 1. So you just put a dot. Where is 1? Where is that? Then you go to the next one. What is it? Negative 180. What is it? I'm getting 0. What are you guys getting there? Let's see. Negative 90. I'm getting negative 1. You put a dot there. Let's go to the next one. It's 0. I'm getting 0. Let's go to positive 90 now. Positive 90, you get 1. Then you put a dot there. Let's go to the next one. 180, you get 0. You put a dot there. Let's see. 270, you get negative 1 there. Let's see. The next one, not there, but below 270. 360, you get 0. So can you see, guys, all that you do is just to connect the dots. So it does that, it does that, it does that, it does that, does that, that. Zinke, can you see how nice it is to plot this type of a function, honorable member? Nothing complicated there. Can you see how nice it is, DJ Zinke? Zintle Ongi, are you there, honorable member? Ongi dema Ongiza. I'm seeing this one
there,
for the first
sir.
time.
Yeah, I'm
Oh,
new.
it's Bongi. Hey,
Yes.
just after you unmuted your mic, that B appeared there. But I'm telling you, honorable member, when you had your mic muted, it was saying Ongi. Hey, now I see. It's Bongi Bongi. Let's see. Precious Nolwazi. Does it make sense, honorable member? Otembele Pama. Are you okay that side, honorable member? Are you sure you are not watching the queen there? I don't trust you, honorable member. I think you are watching the queen. Portia, are you not watching
Yes.
Uzalo there?
No, I'm listening.
Sino Tile, Sino. Are you okay that side, honorable member?
Yes, I'm okay.
100%. So, what makes this type of problems complicated in metric or in grade 12 is because now you have this function shifting. It could shift by 2 units upwards, and at the same time it could shift sideways, where you now have that plus 30 degrees. But I'm telling you, it shifts from there. You just need to understand that this means it has shifted upwards. This, it means it has shifted to the left. I will explain deep in terms of how do you know shifted to the left, how do you know shifted to the right, how do you know shifted up and down. Easy, 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 easy. So now let's sketch the one for cos and see how it looks like. So the one for cos, let's say y is equals to cos angle. And they are going to say where angle is the element of. Sometimes they can say 0 and no, let me make it complicated and say negative 90 and 270 degrees. So I said when you are given something of that nature, you start with that to say, on my Cartesian plane, they want me to start from negative 90. So this is your negative 90 there. You have your 90 positive, 90, 180, 270. So that means you're just going to plot it within that range. Obviously 0 there, 180 there, 270 there. How do you know you have to start there and there? This is what tells you. X is the element of those values. So obviously this is your y-axis. So now let's start to plot. Let's see, you do the same. Cos of negative 90 is equal, I'm getting 0 there. With this one, I'm getting 0. Let's go to the next one. Next one, maybe let's say there is 1 and negative 1. Next one is 0. Let's see with 0, what it gives us 1. Let's go to 90. 90, it gives me 0. 180, it gives me negative 1. 270, it gives me 0. So can you see, all that you do is just to connect the dots. You just connect the dots, Bantu Bakiti. And then it ends there. This is your function of y. It's equals to cos of an angle. I'm sure it makes sense also, this one. I'm not sure if there's anyone who's got a question on that one. But I'm assuming that it does make some sense. Anyone to confirm if it makes some sense?
It makes sense, sir.
Okay, 100%. So remember, guys, these are just the basics. So since we have done for sine and what is it? Cosine. Let's now have a look at the tan graph. Let's have a look at the tan graph. I'm not sure if this is the one that you guys find a bit difficult or challenging. But let's look at that one. Let's say maybe they want us to plot y is equals to a tan of an angle, where that angle is the element of, maybe let's make it worse and say negative 360 and actually it's not worse, it just means you are going to plot it over a full length. Let's say there, and then let's say that there, having the y-axis. So that means, can you see, you focus on that. Let me do that, and that, and and that. So obviously you are having negative 90 degrees, negative 180 degrees, negative 270 there, negative 360 there, 90 there, 180 there, 270 there, 360 there. Okay, so let's see. Sasubuya la. Okay. Obviously 0 there. Here you can just see 1, negative 1. Okay. Now that you are done with that part, then we need to do that one of doing the dots. So let's see. Just going to say tan negative 360. What are you getting there? You are getting 0. I'll use a red there to say we are getting 0 there. Let's go to 270. Hey, it gives us what is it? Error. Yes, error. So where we get error, we do those broken lines, which we call those asymptotes. So that means your function does not touch or cross that. Doesn't touch or cross that. Let's move on. Let's look for another point. Is that one of negative 180? It's 0. So it's 0 there. Let's go to that one of 90. Negative 90, let's see. Hey, error again. Okay, so everywhere we get error, we do that. Let's go to 0 now. 0, hey, I'm getting 0 there. Let's go to positive 90. Hey, it seems like it's error. I'm getting error again. Okay, let's now go to 180. Let's see. 180 gives us 0. I think we're getting somewhere. Let's go to 270. Hey, error. Okay, then we do that. Let's go to 360. 360, it gives 0. Now we need to plot. Now we need to plot, and we can't connect those by having a straight line because our line doesn't cross those asymptotes. But now, Charlotte, here comes the question. How are you going to know whether your function now will go like that, or if it will go like that, or otherwise if it will go like that, or if it will go like that? How are you going to know? That is the main question that you should be asking yourself. So in this case, how can we work it out for us to know how we are going to draw the shape of that tan graph? Anyone who can suggest? Mention your name,
Sir,
and I will
Kabelo,
recognize
sir.
you. Order, honorable members. Who's speaking?
Kabelo, sir.
Honorable member of the opposition party. On what point are you rising on?
So, I'm not sure if I'm correct, but I was gonna give it a try. And since your tan is positive, your graph is gonna have like, yeah, you could say a positive gradient. It's gonna be
Okay. What you have just said, it does make sense to me or to someone who's got a better understanding of this. But there will always be that one honorable member of the opposition party who says, I don't even know how a positive gradient looks like. Do we have another way of explaining that, honorable members? What Kabelo has said is 100% correct. But for you to understand that, you need to be on a different level. If she had to draw that, she was going to get it correct. But I'm just wondering if there's another different way of explaining that.
so like the graph is gonna like start from, I won't say start, but
Let's
from
say
the
starting
negative,
from that dot, then do I go to the right or to the left?
you move to the right, sir, upward.
Like this, nay.
Yes, sir.
100%, exactly what I said. Maybe let me explain it differently and say this is where you need what we call the critical points. Note it down. Kabelo, when you get to school and your teacher asks you, just say critical points, honorable member. But you might not need to say honorable member to your teacher. I'm not sure what they might do. But just say whatever that you say. But most importantly, critical points. What are the critical points? The critical points are these points in between. These are what we call the critical points, honorable members. They guide you regarding the shape of your function. What is between 0 and 90? Is it not 45? What is between 90 and 180? Let's see, just say 90 plus 180 is equals to, you divide it by 2, you get 135. Those are the critical points. Maybe let me use a reader. You get 135. What about between those? Let's see. Can just say 180 plus 270 is equals to divided by 2, 225. 225. What about that one? 270 plus 360 is equals to divided by 2, 315. These are the critical points. So obviously you still have the same thing but having negative values there. Just as I'm not sure if I'm losing some of members of parliament. Bantu Bakiti, do you understand how I'm going to end load shedding, or it still doesn't make sense, honorable members? The critical points. Bongi dama bongizi. Bongi, do you
Hello.
understand, honorable member?
I do, sir.
Regarding
I
the
do.
critical points.
Yes, sir.
Hey, I think I'm going to appoint you to be Minister of Critical Points. Bongi dema bongis. Okay, let's see. Bongi, why do we need the critical points? Because when you say, let's start from there. When you say tan of negative 315, can you see it gives you 1? That's where you make a point. You say, okay, it gives me 1, and 1 is somewhere there. So can you see nicely, you know, from there we go towards the right, and then it gets closer to that, but it never touch, it never cross. Let's go to, obviously we know this one, it gives us error. Let's go to next critical point, which is negative 225. It gives negative 1. Negative 1 below 225 is somewhere there. Let's go to the next one being 135. 135. It gives you positive 1. So positive 1 is somewhere there. So can you see, Charlotte, my initial question? It guides you. Now you know this is how it goes. This is how it goes. Can you see? So that means obviously going forward, you are just going to be having something of that nature. Even though my drawing is like I'm trying to run away, but I know you guys will draw it very nicely. Very nicely. So with regards to this one, you might be wondering whether, but it can't do that, because you can see below the x-axis, it actually goes downwards towards that. So this is how you plot your function of y is equals to tan of that between that range. Guys, did that make sense to everyone, or did I lose honorable members of the opposition party? Are you guys happy?
Sir,
It makes sense.
But does it make sense to everyone? This is the last part of our lesson, Bantu Bagiti. Letoya James. I think you joined late, honorable member. I'm just not sure. But did you manage to get something out of today's lesson?
Yes, sir. Thank you so much.
Especially
the last part. Thank you.
yes, sir.
100%. Who was it? Was it Lotoya or yes? Okay, noted, honorable. Moleboge, kwenze njani namhlanje? Uthulile, are you there? Are you observing, honorable member?
I'm observing. I'm here. I'm listening, sir.
All clear, ne?
Yes, all clear.
Jesus, I need Mzozos to allow me to sign out. I'm not sure if Mzozo. It seems like Mzozo is not there today. Lwandiswa, Mlando. Hey, no, it's not Mlando.
Mlondo.
That O, it was A. I don't know what happened, but you just unmuted your mic. Now I see is Mlundo. But are you okay that side, honorable member? I'm about to sign out.
So I'm okay.
Umi the Umis. Utulile. Do you allow me to sign out Umi the Umis? But
Yes,
I
sir.
almost
Yes.
forgot the code for today's lesson. So this is what happens, Pantibagiti. Every time when you attend our lessons, we give you a code so that your parents can be able to track you whether you are attending or not. So today's code, today's code, you just write the letter of your surname. That's it. The Namfan May as Desmond, the surname is Seko. So you just type S, which is the letter of your surname. So that's how your parents are going to be able to track you, just to check if you've been attending or not. So, ladies and gentlemen, I think that was all for today's lesson. And I'm pretty much sure that you guys did learn a thing or two there. So this was just an introduction. We haven't started Bantu Bagiti. We haven't started. If we are actually taking a trip, going to from Limpopo to Cape Town, we haven't started with our trip. We are just planning nje. Sisacabanga ukuthi sisofika kanjani lapha eKapa. Asinga movie. Hey, you get it? If you don't get it, forget about it. So, ladies and gentlemen, my name is Desmond, and I'm out.
And I'm out.